All right, class, welcome back. So this is 7.3. We're still working on simplifying radicals, but this time we are going to use the quotient rule. What the quotient rule says is that if I have an index, whatever that index is, and if it's 2 or 3 or 4 or 5, and I have a radicand that is a quotient, or in other words is being divided, that this is the same thing as separating those out, top to bottom. So what do some of these look like? Well, if I wanted to see, well, what is the square root of y over 36? Well, I can't simplify y and 36, but I can rewrite it as the square root of y over the square root of 36. Square root of y can't be simplified because there's just a single y, and I would need 2 of them. So this is still just going to be the square root of y. But this can be simplified. The square root of 36 is just going to be 6. So by separating them out, by using this rule here, we can separate them out and simplify it. Another example, a cubed root. So let's say it's negative 27 over 64. Well, the cubed root of negative 27 over the cubed root of 64. Cubed root of 27, if I divide these out, it's 3 times 3 times 3, and those are all negatives. So this would be a negative 3, and the cubed root is 4 times 4 times 4 of 64. So this would be a 4. So this would be my answer. It's negative again because this sign right here is negative. When you have an odd index, you can have a negative radicand. Again, what this means is that if I took negative 3/4 and I multiplied it by itself 3 times, I would get negative 27 over 64, the radicand that we started with. Okay, so let's do one more for practice. I'll write it down and give you a minute to work on it. Well, actually, you should just pause the video and try to do this one yourself. So go ahead and work on that one for just a minute. Okay, so hopefully you've paused the video, and I'm going to write this as a separate radical with the index of 4, but just over both. Again, remember that means that I'm looking for anything to the 4th power or a factor 4 times so I can pull it out. If I were to factor 16 down, it would be 2 to the 4th power. So when I'm looking at this, on top, there's nothing I can do here. I'm just going to have the 4th root of 3. But on the bottom here, the 4th root of 16 is 2. And the 4th root of y to the 4th is just y. Again, if I were looking at 16, it factors out to 2 times 2 times 2 times 2. There are 4 of these factors, so 1 can come out. Same thing with y to the 4th. This is y times y times y times y. There are 4 of these factors, so 1 can come out. To look at it at an exponent view, this would say 2 to the 4th, y to the 4th. I'm taking the 4th root. When these exponents are the same, then I just bring out the base. So that is simplifying when I have it under 1 to separate it to 2. But what if I'm given it with 2 radicals and try to simplify that? So I have the square root of 20 over the square root of 5. Well, simplifying the square root of 20, I can simplify it, but I can't simplify the square root of 5. So if I write this all like under 1 hat or 1 radical, 20 divided by 5 is 4. So the square root of 4 is equal to 2. It makes it a lot easier to simplify when it's under 1. So basically, if they give it to you under 1, you probably want to separate it out to 2. If the problem has 2, then you probably want to put it under 1. So another example of this. Let's do the square root of 80w over 3 root 5. Okay, now notice that this 3 is not under the radical. So if I'm going to rewrite this expression here using 1, I'm going to have a 1 on the outside and a 3, right? This is just a 1/3. You can think of it as a 1. We don't need the 1 there though. But what is going to be underneath this radical now is 80w over 5. Well, I can divide 80 by 5. That is going to be the square root of 16w. The square root of 16 is going to be 4. And remember, when I pull this out, it's related through multiplication. So I have 4, but this is still the square root of w. There's only a single w here, so I can't pull it out. So 1 times 4, excuse me, is going to give me 4. And that square root of w is going to be on the top. And that is going to be over 3. So this would be the simplified version of this square root of 80w. Again, this 3 has to stay outside. Only if the bases here are inside the exponent can you write them with them under 1. So that 3 is a constant. It has to stay outside as a constant. Okay, let's do one that's a little bit more difficult. So this will be the last one that we're going to do. So suppose we have 7 times the cubed root of 48x to the 4th, y to the 8th, all over the cubed root of 6y squared. Okay, again, this 7 here is a constant, so we can't put it under the hat or under that radical. We have to keep it outside. So if I were going to rewrite this, I would write it as 7, then the cubed root of 48x to the 4th over y to the 8th, all over 6y squared. I'm going to do the division of 48 divided by 6, which is 8. And x to the 4th, there's nothing to simplify, so it's just going to be x to the 4th. Y to the 8th, I have y to the 8 minus 2, because that is the relationship of these exponents. Or in other words, I have 6 more y's upstairs. So this turns out that this is only a radical now with a numerator, because everything in the denominator canceled. So now I want to go through and simplify what I can within this radical. 8 is a perfect cube, so we're going to pull out the 8. But remember, the relationship with the 7 is multiplication. Anything that's on the outside is related to multiplication. So the cubed root of 8 is 2. The cubed root of x to the 4th, what I need to do here is I need to separate this out into multiples of 3. So I'm going to have x cubed and x. Well, x cubed is a perfect cube and it can come out. X cannot, so it is going to stay under. And y to the 6 is a perfect cube because it is a multiple of 3. So 3 times 2 would be 6. If I take 6 here and divide it by 3, then I get y squared. So again, we have all of these on the outside are related through multiplication. So we would write this as 14x y squared cubed root of x. And this would be the simplified version of this original problem. This is a more complex one, but definitely doable if you just take step by step and simplify as you can. All right, so that is simplifying radicals using the quotient rule, and this here is the quotient rule of radicals.